In Module 1, we explore the role of technology and digital construction, from building information modeling to robotics, modular construction, and smart materials. We saw how innovation is reshaping the way projects are designed and delivered. Now, in Module 2, we shift our focus to two other critical themes in contemporary construction: sustainability and procurement. Sustainability has become one of the most pressing issues of our time, influencing how we design, build, and manage construction projects. Alongside this, procurement, the strategies and processes used to acquire goods, services, and works, plays a decisive role in determining project outcomes. Together, these two themes provide a powerful lens for evaluating today's construction industry. Section 1: Understanding sustainability in construction. Sustainability, in its simplest sense, means meeting the needs of the present without compromising the ability of future generations to meet their own needs. In construction, this principle translates into minimizing negative environmental impact, promoting social responsibility, and ensuring economic viability. The construction industry is a major consumer of natural resources and a significant contributor to carbon emissions. Buildings alone account for around 40% of global energy consumption and a third of greenhouse gas emissions. Construction also generates vast amounts of waste. These realities make sustainability not just desirable, but essential. Sustainable construction aims to reduce energy consumption and emissions, use resources efficiently, minimize waste through recycling and reuse, protect ecosystems and biodiversity, create healthy and safe environments for occupants. Section 2: Environmental challenges and carbon footprint. One of the greatest environmental challenges in construction is the carbon footprint. This footprint has two major components: embodied carbon, emissions associated with producing, transporting, and assembling building materials. For example, cement production alone contributes about 8% of global carbon emissions. Operational carbon, emissions from energy used during the building's life, such as heating, cooling, and lighting. To address these challenges, sustainable construction emphasizes strategies such as using low-carbon materials like fly ash concrete, recycled steel, or engineered timber. Designing for energy efficiency through insulation, natural ventilation, and renewable energy. Implementing construction methods that reduce transportation and material waste. Addressing carbon footprint is not only an environmental necessity but increasingly a legal and financial requirement, as governments set stricter building regulations and clients demand greener solutions. Section 3: Green Building Standards and Certifications. To measure and encourage sustainable practices, several green building standards and certifications have been developed. Some of the most widely recognized include LEED, Leadership in Energy and Environmental Design, a US-based system that rates buildings on sustainability criteria such as energy use, materials, and water efficiency. BREEAM, Building Research Establishment Environmental Assessment Method, a UK standard that assesses projects across categories including energy, health, transport, and waste. WELL Building Standard, focused on occupant health and well-being, measuring factors like air quality, lighting, and comfort. EDGE, Excellence in Design for Greater Efficiency, is a World Bank initiative designed for emerging markets, focusing on cost-effective green solutions. These certifications provide benchmarks, motivate innovation, and offer assurance to clients and stakeholders that a building meets sustainability goals. Section 4: Sustainable Materials and Methods. Innovation in materials and methods plays a major role in achieving sustainability. Some important examples include recycled and reclaimed materials. Using recycled steel, reclaimed wood, or crushed concrete reduces demand for virgin resources. Engineered timber. Cross-laminated timber provides strength comparable to steel and concrete but stores carbon rather than emitting it. High-performance insulation and glazing improve energy efficiency in operation. Green roofs and walls reduce heat islands, support biodiversity, and improve insulation. Passive design methods. Designing buildings to use natural ventilation, sunlight, and shading reduces reliance on mechanical systems. Sustainability is not just about choosing the right materials, it is also about the process of construction. Prefabrication and modular construction, which we discussed in Module 1, reduce waste and improve resource efficiency, aligning with sustainability goals. Section 5, Circular Economy in Construction. A growing concept in sustainability is the circular economy. Unlike the traditional linear model of take, make, dispose, the circular economy seeks to design out waste, keep materials in use for as long as possible, and regenerate natural systems. In construction, this means designing buildings for disassembly, so materials can be reused. Creating marketplaces for second-hand construction materials. Recycling demolition waste into new products. Extending the life of buildings through renovation rather than demolition. This shift is profound, as it challenges the long-standing culture of disposability in construction. It encourages viewing buildings not just as end products, but as material banks for the future. Section 6, Social and Economic Dimensions of Sustainability. Sustainability is not only about the environment. It also includes social and economic dimensions. Social sustainability involves ensuring safe and fair working conditions on construction sites, providing access to affordable and inclusive housing, creating spaces that support health, well-being, and community. Economic sustainability involves delivering projects that are cost-effective over their life cycle, not just at initial construction. Supporting local economies by sourcing materials and labor locally. Ensuring long-term value for clients and communities. A sustainable project balances environmental, social, and economic factors, often referred to as the triple bottom line. Section 7, Procurement in Modern Construction. Having explored sustainability, we now turn to procurement. Procurement refers to the processes and strategies used to acquire the goods, services, and works needed to complete a project. Why is procurement important? Because the way a project is procured strongly influences its cost, quality, timeline, and even sustainability outcomes. Poor procurement can lead to disputes, overruns, and dissatisfaction, while effective procurement can ensure efficiency, collaboration, and long-term success. Procurement is not just about buying materials at the lowest price, it is about strategically managing relationships, risks, and responsibilities. Section 8, Traditional versus Modern Procurement Approaches. Historically, construction procurement followed the traditional design-bid-build method. In this approach, the design is completed first, then contractors bid to build it. While this method ensures competition and clear roles, it can also lead to fragmentation, adversarial relationships, and delays. Modern approaches aim to overcome these challenges by promoting collaboration and integration. Examples include design and build. A single entity is responsible for both design and construction, improving coordination. Construction management. The client appoints a manager to oversee the construction process, allowing more flexibility. Integrated project delivery. IPD. All parties, client, designers, contractors, share risks and rewards, working collaboratively from the start. These methods recognize that construction is too complex to be treated as a simple transaction. Success depends on trust, communication, and shared goals. Section 9, Public-Private Partnerships, PPPs. One increasingly important procurement strategy is the Public-Private Partnership, or PPP. In a PPP, a private company partners with a government agency to deliver infrastructure such as roads, hospitals, or schools. The private partner often finances, builds, and sometimes operates the project, while the public sector provides oversight and long-term payments. The advantages of PPPs include access to private sector financing and expertise, risk-sharing between public and private entities, faster delivery of critical infrastructure. However, PPPs also face criticisms, such as complex contracts, potential lack of transparency, and the risk of prioritizing profit over public interest. Section 10, Challenges and Future Directions in Procurement. Procurement in contemporary construction faces several challenges. Complexity. Modern projects involve many stakeholders with diverse interests. Risk management. Allocating risks fairly is often contentious. Sustainability integration. Procurement must ensure not only cost efficiency but also environmental and social goals. Digital disruption. Technologies such as e-procurement platforms, blockchain, and smart contracts are beginning to reshape procurement processes. The future of procurement will likely be characterized by greater collaboration, transparency, and digitalization. Procurement strategies will increasingly be judged not just on cost, but on their ability to deliver sustainable, resilient, and socially responsible outcomes. Conclusion of Module 2. We have now reached the end of Module 2. Let us briefly recap. In this module, we examine sustainability and procurement as central themes in contemporary construction. We explore the environmental challenges of the industry, the importance of reducing carbon footprints, and the role of green building certifications. We considered sustainable materials, methods, and the concept of the circular economy. We also discussed the social and economic dimensions of sustainability. Then we shifted to procurement, looking at traditional and modern approaches, public-private partnerships, and the challenges facing procurement today. We saw how procurement decisions shape project outcomes and how the future may be influenced by collaboration and digitalization. Final course wrap-up. Across both modules, we have studied the three core themes shaping the construction industry today: technology, sustainability, and procurement. Technology is driving digital transformation through BIM, robotics, and new construction methods. Sustainability is pushing the industry to rethink its environmental, social, and economic responsibilities. Procurement strategies are evolving to reflect the complexity and ambition of modern projects. Together, these themes paint a picture of an industry in transition, one that is facing challenges but also seizing opportunities to innovate, adapt, and contribute to a more sustainable and resilient world. That concludes our course on contemporary construction themes. Thank you for your engagement, and I encourage you to keep exploring these issues as you move forward in your studies and careers.